Hey everyone, and welcome back. Today we are going deep into the world of chiller plant optimization.
Ooh, that's exciting.
I know, right? It's pretty cool.
Yeah.
So have you ever wondered what keeps those massive buildings, cool and comfortable?
Oh, yeah, all the time, especially here, living in a place where it's warm most of the year.
Right.
It's amazing how these giant buildings stay so comfortable inside.
Yeah. So we're gonna uncover those secrets behind those humming giants today.
It's an area with a lot of really cool technology
Yeah.
and a ton of opportunities that people often just completely overlook.
Yeah, it's not just like your window AC unit or something like that.
No.
These chiller plants are like the heart of climate control for these entire
The
facilities.
entire facilities,
Yeah,
yeah.
it's pretty amazing.
Mm-hmm.
And we've got a pretty awesome lineup of sources for you today.
Oh, yeah.
Yeah, we're going to be looking at Dakin's iPlant Manager system.
Okay.
And you can think of that as like mission control for your chillers.
Okay.
But we're also going to zoom out a little bit
All right.
and look at the bigger picture of just process cooling and refrigeration in general.
I like it.
Yeah, there's so many potential savings that are just hidden in plain sight.
Oh, I bet. Yeah, people don't realize how much energy and money they're just like literally chilling out the window.
Literally.
Yeah.
That's crazy.
Inefficient systems are everywhere.
Yeah, and by the end of this deep dive,
Mm-hmm.
you're going to understand not only how these systems work, but also how to start identifying those hidden savings in your own facilities.
That's the goal?
That is the goal.
Yeah.
So let's kick off this chiller party.
Let's do it.
Okay. So first things first, imagine a chiller plant as the heart of a building.
Okay.
It's constantly pumping chilled water through a network of pipes to keep everything, cool and comfortable.
I see.
That's kind of like how our circulatory system keeps us going.
Right, like our bodies.
Yeah.
Okay.
And so just like a healthy heart is crucial for our well-being, a well-optimized chiller plant is key to a building's energy performance.
Mm-hmm. Makes sense.
Traditional building management systems, or BMS systems that you might have heard of,
Yeah.
they often just struggle to handle the specialized needs of chiller plants.
Yeah, they're not really designed for that.
It's kind of like trying to control a high-performance sports car with the controls from a clunky old truck.
That's a great analogy.
Yeah,
It's just, they're just not designed for that level of like finesse.
exactly.
Yeah.
So that's where Dakin's iPlant Manager steps in, or IPM for short.
Right.
And it's like upgrading to a Formula One racing team
Oh.
for your chiller plant.
Wow. Okay, that's a serious upgrade.
Right.
Yeah.
So what makes this iPlant Manager so special?
Well,
Is it just for these fancy buildings, or can anyone use it?
it's surprisingly versatile.
Okay.
One of the things is it has this incredible embedded intelligence.
Yeah.
So it's not like just reacting to preset temperatures or something.
Right.
It's constantly analyzing data,
Yeah.
learning the building's patterns, and adjusting to optimize the entire plant's operation in real time.
Hold on. It learns.
Yeah,
Like it gets smarter over time.
it does. That's wild.
Yeah. And the best part is it's not picky about the equipment that it works with.
Okay.
So it can work with chillers from any manufacturer,
Oh, wow.
not just Dakin chillers.
So it's not like a proprietary...
No, it's not a proprietary system.
Oh, that's amazing.
Yeah, you can think of it like a universal translator for chiller plants.
I like that.
Yeah,
So it can talk to all the different brands and make sure everything is working together.
exactly. Ensures that smooth integration regardless of the brand.
I'm intrigued, I gotta say.
Yeah.
So let's talk about AI and machine learning,
Okay,
because that's like a real game changer that was mentioned in a lot of the sources.
absolutely.
So how does that fit into all this?
Okay, so imagine you have a chiller plant expert
Okay.
that's constantly monitoring and fine-tuning your system 24/7.
Yeah. Right. That's essentially what IPM does with AI.
Really?
Yeah, it sifts through mountains of data, predicts performance hiccups before they even happen, and optimizes every aspect of the plant's operation.
That's incredible.
Yeah.
So it's like preventative maintenance in a way.
It is, yeah.
That's amazing.
Yeah, we call that smart cooling.
Smart cooling. I love it.
Yeah.
Could you give us like a concrete example of this AI magic in action?
Sure. One of the coolest features is smart flow optimization.
Okay.
And this is where things get really interesting.
Oh,
So IPM doesn't just control the chillers,
right.
it dives deep and learns the power usage patterns of everything connected to the system.
Oh, wow.
So the pumps, the cooling towers, you name it. Based on the cooling loads, temperatures, flow rates, the whole 9 yards.
So it's like building a digital twin of the entire system.
Yes, exactly.
Constantly analyzing and tweaking things to make sure that it's running at maximum efficiency.
That is a great way to put it.
That's so cool.
It is, yeah. And then it crunches all that data to calculate the absolute best combination of strategies to keep the building comfortable
Right.
while using the least amount of energy.
So it's not just about, like, the individual components.
Right.
It's about orchestrating the entire system for peak performance.
Exactly. It's all about the system.
That's seriously impressive.
It is.
But does all this fancy tech actually translate into real-world results?
It does.
Or is it just a bunch of theoretical mumbo-jumbo?
No, it's the real deal.
Okay, good.
We've got case studies that are really compelling.
Okay, let's hear it.
Like, for example, there's this hotel in Singapore
Okay.
that was already pretty efficient,
Okay.
but after they installed IPM, their efficiency just skyrocketed.
Really?
We're talking like a dramatic improvement in kilowatt per ton.
Ooh, now you're speaking my language.
Yeah.
Measurable result.
Measurable results.
I like it. So are there any other examples that prove this isn't just a fluke?
Oh, yeah, definitely.
Okay.
There's this university campus also in Singapore, and they also experienced significant efficiency gains.
Mm.
But what's really interesting is how IPM adapted to their unique schedule.
What do you mean?
So it figured out the difference in energy demands between semesters and holidays,
Oh, wow.
and it adjusted its strategy accordingly.
That's really smart.
It is.
So it's not just like a set it and forget it system.
No.
It's constantly learning and evolving to match the building's needs.
Constantly learning, always evolving.
I'm impressed.
Yeah, and remember, these aren't just like anecdotal improvements.
No.
We're talking hard data with specific numbers for efficiency gains and payback periods.
So this stuff really pays off.
Oh, yeah, it really does.
That's great.
Yeah.
Now, we've been focusing on chiller plants specifically,
Right.
but it sounds like these principles could apply to a whole range of systems.
Absolutely.
Like, what about other parts of the building or even industrial processes?
You're right on the money.
Okay, good.
What we've been discussing with chiller plants, it's just the tip of the iceberg.
Ooh, I like that.
Yeah.
So it's like we're zooming in on this one critical component,
Right.
but now we're going to start to pan out and see how it fits into the bigger picture
Exactly.
of energy efficiency.
Exactly.
Okay, so this is where it gets really interesting.
That's where it gets really interesting.
I'm excited.
So think about it. Chiller plants are just one piece of a much larger puzzle
Right.
when it comes to industrial energy use.
Yeah.
So we've got pumps, fans, motors, entire distribution systems.
It's a lot.
It is a lot, and it all works together.
Right.
And it all contributes to the overall energy consumption of the facility.
And just like in the chiller plant itself, there's got to be a ton of untapped potential in these systems
Oh, yeah, absolutely.
for optimization and savings.
Absolutely.
Like a whole hidden world of energy efficiency just waiting to be discovered.
Just waiting to be discovered.
I love it.
Yeah, you know that YouTube video that we watched?
Yeah.
It highlighted that process cooling can eat up like 15 to 40% of total energy consumption in energy-intensive industries.
That's a huge chunk of the energy pie.
It's a huge chunk.
That's wild.
It is, yeah.
So if we're serious about making a dent in industrial energy use,
Right.
process cooling optimization has to be a top priority.
It has to be.
It's not just about saving money at this point.
Right.
It's about creating a more sustainable future.
Yeah, I couldn't agree more.
Yeah.
But here's the catch.
Okay.
We can't just look at each component in isolation.
Okay.
We need a more holistic approach
Okay.
that takes into account the interactions and trade-offs between all these different parts of the system.
Oh, so it's like an intricate dance
It is.
where every move affects the others.
Exactly.
Okay, so I'm starting to see how complex this can get. It's not just about like tweaking a few settings here and there.
No, it's not.
It's about understanding the entire ecosystem of energy use in the facility.
You got it.
This is complicated.
It is, yeah. And that's why it's so crucial to have a deep understanding of how these systems interact.
Okay.
Like, for example, if we make a change to the chiller,
Right.
that saves energy,
Okay.
but it causes a pump to work harder. We might end up losing those gains.
Oh, so it's all about finding that sweet spot for optimal performance across the entire system.
It is all about the sweet spot.
Wow.
Oh,
Yeah. Yeah, so we need to think strategically and consider the whole system, not just like the individual pieces,
Right.
but how do we even begin to tackle something this complex?
Yeah.
Like it feels a bit overwhelming.
I get that it's definitely a lot to wrap your head around, but
Yeah.
but there are some like practical tools and strategies that can
Okay.
help us navigate this energy maze.
Okay, good.
You know those rules of thumb we talked about?
Yeah.
Those are a great starting point.
Right, those little nuggets of wisdom.
Yes. Exactly.
will make a big difference.
They really can.
To remind us about some of those key strategies
Okay.
for squeezing every ounce of savings out of our process cooling systems.
All right. Well, one of the simplest but most effective tricks is focusing on the condensing water temperature. So each degree Celsius reduction in that entering temperature
Okay.
can boost chiller efficiency by 1 to 2%.
Really? Just 1 degree?
Just 1 degree.
Wow.
It's like getting a free energy boost.
I'm like free.
Yeah.
Free is good. So even like small tweaks can lead to big savings over time.
Exactly. It's the compounding effect.
The compounding effect. I like, what else can we do to make our systems, run leaner and meaner?
Well, we can flip that logic around and look at the chilled water supply temperature.
Great.
So if you bump that up by a single degree Celsius, you can also get a 1 to 2% efficiency gain.
Wow. So it's kind of a delicate balancing act.
It is.
Finding that sweet spot between keeping things cool and minimizing energy waste.
Exactly.
Like optimizing a recipe.
Yeah.
Finding the perfect balance of ingredients to create a masterpiece of efficiency.
I like that analogy.
So every system is different though, right?
Every system is different.
Like we can't just blindly apply these rules of thumb
No.
without understanding the specific quirks of our facility.
You're absolutely right. And that's where data comes in.
Data.
Data is king.
Okay, everyone loves data.
Right. But it's not enough to just collect it.
Right.
You have to analyze it, understand it, and use it to make informed decisions.
So it's like being a detective.
It is.
Searching for clues.
Yes.
To unlock the secrets of energy efficiency.
You got it.
I like that. So we've got our rules of thumb. We've got our data.
Mm-hmm.
What about real-world application? Like, let's say I'm responsible for a building, and I suspect there are some energy hogs lurking in my chiller plant.
Okay.
Where do I even begin?
Well, first and foremost, get to know your system intimately. Like, really well. Walk the plant room, talk to the operators, and really understand how everything works.
So it's about observation.
Yes.
And information gathering.
Absolutely.
Like a doctor doing a thorough checkup before prescribing any treatment. Okay, so what comes next?
All right, so once you have that solid baseline understanding, you can start identifying those areas that are ripe for improvement. And this is where those performance benchmarks and rules of thumb really come in handy. So compare your current performance to industry standards and see where you have room to grow.
So it's like having a roadmap for energy efficiency.
It is.
We know where we are and we have our destination in mind.
Exactly. You got it.
Sometimes even with a map, though,
it
helps to have a guide.
Absolutely. And you know what? Don't be afraid to call in the experts.
Yeah, call in the cavalry.
Yeah, there are so many energy professionals out there who specialize in this stuff, and they can provide invaluable insights and guidance.
So it's like there are personal trainers for energy efficiency.
Exactly. They can help you get in shape
rip.
And reach peak performance.
I like it. So it's a combination of knowledge, data, and expert advice.
It is.
But even with all the right tools and guidance, I imagine maintaining that optimal performance requires like ongoing effort, right?
It does.
It's not just a one-time fix.
Not a one-time fix.
It's a lifestyle.
It is. It's like physical fitness.
Right.
Achieving and maintaining peak energy efficiency is a continuous journey. It's about making adjustments, tracking progress, and always looking for ways to improve.
It was a marathon, not a sprint.
It's a marathon, not a sprint. You got it.
And the beauty of this marathon is that every step we take towards greater efficiency brings real tangible rewards.
Absolutely.
We're talking lower energy costs, a smaller environmental footprint, and a more sustainable operation.
It's a win-win-win.
It is. It's a win-win-win.
Yeah.
I like winning. So now while we're feeling all inspired by this whole energy efficiency movement, let's take a peek into the future.
Okay.
Our source material hinted at some pretty mind-blowing technological advancements on the horizon.
It did.
So what can we expect to see in the coming years?
All right, well, hold on to your hats because things are about to get really futuristic.
Okay.
One area that's absolutely exploding right now is predictive maintenance.
Predictive maintenance?
It's like giving your chiller plant a crystal ball.
Okay, that sounds pretty sci-fi.
It does.
Tell me more.
All right, so imagine being able to see into the future and knowing exactly when a component is likely to fail.
That would be nice.
Right. That's what predictive maintenance is all about.
Really?
Yeah.
How does that work?
By harnessing the power of sensors, data, and machine learning, we can now anticipate potential problems before they even arise.
So instead of waiting for something to break down and cause chaos, we can proactively address these issues and keep everything running smoothly.
Exactly.
So it's like having a team of tiny robots constantly monitoring the health of your chiller plant.
I love that visualization.
That's what I was going for. And this technology is not just about preventing those costly downtimes. It's also about extending the lifespan of the equipment.
Absolutely.
And optimizing those maintenance schedules.
Exactly. It's about making smarter decisions, not just reacting to problems after they occur.
Right. So being proactive. Staying ahead of the game.
You got it.
Sounds like a real game changer for facility management.
It is a game changer.
What other futuristic technologies are shaking things up in the chiller plant world?
Well, get ready for this one. Digital twins.
Digital twins.
This is where things get seriously mind-bending.
Okay.
Imagine having a virtual clone of your entire chiller plant.
Whoa.
A digital replica that mirrors every detail of the real system.
That's like something straight out of a sci-fi movie.
It is.
What's the point of having a digital twin?
So think of it as a virtual laboratory where you can run simulations, test different scenarios, and optimize performance without any risk to the real system.
Just like having a flight simulator.
Exactly.
For your chiller plant.
A flight simulator for your chiller plant.
That's amazing.
It is.
So we can experiment with different control strategies.
Yes.
Simulate equipment failures.
Yes.
Even test new technologies.
Absolutely.
All within the safety of the digital realm.
Yes. It's like having a sandbox for energy efficiency.
It is. That's incredible. So this kind of simulable allows us to achieve a level of precision and optimization that was just unimaginable a few years ago.
Oh, yeah. It's like having a superpower for chiller plant management.
It's a lot to take in.
It is.
But before we get carried away with all this futuristic tech, let's bring it back down to earth for a moment.
Okay.
I imagine there's some practical challenges to implementing these advanced technologies, right?
Yeah.
It can't all be sunshine and rainbows.
No, you're absolutely right. While these technologies offer incredible potential, there are some real-world hurdles we need to address.
Like what?
Well, one of the biggest challenges is data integration.
Yeah. We've talked about data being the lifeblood of optimization.
Right.
But getting all those different systems to play nice together can be a real headache.
It can be a nightmare.
Yeah, it's like trying to get a room full of people speaking different languages to understand each other.
Exactly. And chiller plants often have a mix of legacy equipment and newer systems, each with their own quirks and communication protocols.
This is a mess.
It can be a mess. So bringing it all together into a cohesive data stream can be a very complex and costly process.
So it's about finding a way to bridge the communication gap between the old and the new.
Exactly.
But what about security?
Okay.
With all these connected devices, doesn't that increase the risk of cyber attacks?
It does.
It's a bit scary to think about, our critical infrastructure being vulnerable.
Yeah, cybersecurity is absolutely paramount.
Yeah.
As we move towards a more connected world, we need to build strong defenses.
Right.
And protect our systems from malicious actors.
So it's like building a fortress around our data.
It is.
Okay, I like that visual. So it's a balancing act.
It is.
Between embracing the power of connectivity while also mitigating the risks.
Absolutely.
It's a constant evolution.
It is.
Trying to stay one step ahead of the bad guys.
Yeah, you got to stay ahead of them.
But even with the best technology and security measures in place, I imagine the human element is still crucial.
It is absolutely. We can't just throw technology at a problem and expect it to magically solve itself.
Yeah.
We need skilled people who understand these systems, can interpret the data, and make informed decisions.
So technology is a tool.
Yes.
But it's the people who wield that tool and make it work effectively.
Exactly.
It's about empowering our workforce to become energy efficiency champions.
You got it.
So we need to invest in training development.
Absolutely.
And create a culture of continuous learning.
I couldn't agree more.
So we're equipping people with the knowledge and skills, not only to operate these systems, but also to continuously innovate.
Yes.
And find new ways to optimize performance.
It's all about continuous improvement.
So it's a blend of cutting-edge technology and good old-fashioned human ingenuity.
It is.
It's about fostering that culture of innovation.
Yeah.
And empowering our people to be the best they can be.
Absolutely. But Even with all the excitement surrounding these advanced technologies,
Right.
we can't forget the fundamentals.
Yeah.
The rules of thumb,
The
the
basic.
data analysis, the understanding of system interactions.
Right.
Those core principles still hold true.
So it's about building that strong foundation.
Yes.
And then leveraging technology
Yeah.
to take us to that next level.
Exactly.
Yeah, it really is. Like, we're building this super efficient, high-tech, energy-saving machine.
Yeah.
But the most important part is still that human element.
It is the human element. Yeah. You can have all the fancy gadgets and algorithms in the world, but without skilled and knowledgeable people to operate and maintain them, it's all for nothing. It's the people who make this happen.
Right. It's that human touch that brings it all together.
Mm-hmm.
And speaking of humans,
Okay.
I want to kind of shift our focus to our listener for a moment.
Okay.
Because after all, this whole deep dive is about empowering you with knowledge and insights.
Absolutely. So, listener, we've covered a lot of ground today.
We have.
From the nitty-gritty of chiller plant operation
Yeah.
to the mind-blowing potential of AI and digital twins.
Right, all the cool futuristic stuff.
Yeah, we've explored the rules of thumb, the data analysis, the system interactions, the whole shebang.
The whole 9 yards.
Now the question is...
What are you going to do with all this information?
Yeah, what are you going to do?
That's the million-dollar question. We don't want this to just be an intellectual exercise.
Right.
We want you to walk away from this deep dive feeling inspired and ready to take action.
Ready to take action.
So, listener, we challenge you
Me too.
to take a moment and think about your facility.
Yeah.
Your systems.
Your system.
Your role in this whole energy efficiency equation. What can you do right now to make a difference?
Today.
Maybe it's as simple as like walking through your plant room and observing the systems in action.
Yep.
Maybe it's diving into your data logs and looking for patterns.
That's a good one.
Or maybe it's reaching out to an energy expert for a consultation.
Oh, great ideas.
Whatever it is, just take that first step.
Take that first step.
Remember, even small changes can have a ripple effect.
I really can.
Every kilowatt hour saved, every degree of efficiency gained, contributes to a more sustainable future.
It does a more sustainable future for all of us.
For all of us. And don't forget, you're not alone on this journey.
You are not alone.
There's a whole community of energy efficiency enthusiasts out there.
Oh, yeah.
People who are passionate about making a difference and are eager to share their knowledge and experience.
Absolutely.
So reach out, connect, learn from each other.
Yeah, we can do this together.
Together we can create a world where buildings are not just comfortable and functional, but also energy efficient and sustainable.
That's the dream.
That is the dream. And on that note of collective action and shared inspiration, I think it's time to wrap up this deep dive.
It has been a pleasure exploring this fascinating world with you.
Likewise.
Yeah.
We've covered a lot of ground today.
We have.
And I hope you've gained some valuable insights and practical takeaways that you can apply in your own work.
Absolutely. And as we always say,
stay curious.
Stay curious.
Keep learning.
Keep learning.
And never underestimate the power of a well-optimized chiller plant.
Never.
That's a wrap, folks.
It is.
Thanks for joining us on the deep dive.
Yeah, thanks for listening.
Until next time.
See you next time.
Keep those chillers running cool and those minds engaged.
And remember,
every degree counts.
Every